Hi, welcome back to the Calculus 1 lecture series. And this is in our second unit, the derivatives. This is lecture number 12. We're going to talk about a very, very important implicit differentiation. It is a very important skill when we try to take the derivative. We're also going to divide this lecture into two parts. So the first part, we're just going to introduce the general implicit differentiation skill. Then the second part is we're going to use this method, try to help to derive what is the derivative formula for the inverse trig functions. Okay. All right. So let's start here. Okay. So let's go to our lecture notes worksheets. So the first thing is here. Okay, so before we start, let's take a look. What is this implicity means here? Okay, so like so far, when we try to do the the derivative, we always have like, for example, y is equal to, for example, some like x squared minus 2x plus square root of x plus ex, right? So sometimes it's a very complicated function, sometimes not too bad. Then you can take the derivative. So you can say y prime is equal to what, right? Based on the different rules, we will talk about before. But now we have sometimes we run into a problem here. So for example, instead of like the y can be write out as a function of x, how about if you have x squared y squared plus 3yx minus like x cubed equal to 3x here. So how about if I have equations like this? Then I want to find what is the y prime here, right? Or you want to find what is dy dx here, right? So for this type of the problems here, as you can see, x and y, they mix together, okay? So of course you can say, hey, I can try to solve, I can just like, for this function here, I can use some of my algebra skill and I can try to solve to see, maybe I can solve it to y equal to some type of the function f of x, right? Try to solve it. But like in here, you see you have y squared y, and probably it's not easy, right? So probably it's not easy to solve y, specifically is the expressions of the x's here, okay? So now this type of the, the function we call the implicity functions, because x and y they mix together. It's very difficult to find a y just equal to a function of x. All right, that's what we call this definition of the implicity. Okay, so now let me try to write it out for you, like what we will just discuss that. Okay, so we say if y is a function, so it's function of x defined by an equation let me erase here, not, okay, not of the form, y equal to f of x, okay? Then we say y as a function of x defined implicitly by the equation. Okay, So the key word here is that, the f of x is not of the form. That means you cannot change it to these forms here of y equal to f of x. So then we'll say y is a function of x implicitly by the equations here. So I know, it's not in the form, but if I really want to solve it, I probably still can. So I know the y is a function of f of x. It's just I cannot solve it, right? It's difficult to solve. Okay. So now how do I do that? So the key concept to use is what? The key concept to use is chain rule. Okay, so we know y is a function. So we need to treat y as a function of f of x. It's just we cannot see it. All right. So the things here. So how do we find the derivatives here? So we say find the derivative. So here is the process we do. We say find the derivative with respect to x on both sides of the equation. Okay. Okay, so then apply the chain rule concept when deal with the derivative of y. Okay, so when you're dealing with y, you probably need to wind the chain rules here. Now, the second step here is solve for dy dx. That's what we want, right? So the solve for dy dx is here. So for the implicit differentiation, the derivative is not bad to get, and the chain rule concept is not too bad. The only things here is, when you do the implicit differentiation, you might need a lot of algebra. Good algebra skill certainly will help. Okay, so good algebra skill will help here, right? Because we need the good algebra skill, try to combine the terms, those things. Okay, so now let's take a look here. Let's try to find some example and try to do it. So the key things to remember is whenever you do the derivative for y's here, don't forget you need to use the chain rule concept. All right, so now let's take a look at this one. I think after a few, you will get familiar with that. Okay, so the first term, I said, okay, take the derivative with respect to the x on both sides, right? So here, so this is a 3x squared. All right, so 3x squared, take the derivative, what is here? 6x. Okay, so this is just a pure, you take the derivative to the 3x squared. Okay, now you say plus. Okay, so now remember here, this is a y to the fifth, correct? I know y is a function of what? Y is a function of f of x, but I just cannot, try to write it. So by using the chain rule, so my first layer, it will be the y's, right? So I use the chain rule, so I take the derivative here. So it will be 5 what? 5y to the what? The fourth powers, right? Then don't forget for your chain rule, y to the fifth power is the first layer. So what do you need to times here? You need to times what? Y primes here, because y is a function of f of x, correct? And then here, the 10, this is, you take the derivative for x, what is the 10th here? 10th here is 0. Okay, so let me do like a little table we always did before. So just for the y to the fifth here, right? So the y to the fifth, remember y is equal to the function of f of x. I just don't know how to write it, but that is. So this will be, so the first layer will be the f of x, right, to the fifth powers, right? So this is my first layer, is the power rule. And then my second layer here is what is f of x. This is my what? This is my second layers, right? Okay, so now applying the power rule, the chain rule. So this will be the phi to the f of x to the fourth power, then f prime x, right? Then this one's here, f of x is y, so this is phi to y to the fourth. Then f prime x, you can treat as y prime here. That's how do I get phi y fourth times y prime. And now you want to find the dy dx. So I know the dy dx is equal to the y primes, right? So now you can say, hey, I minus 6x both sides. So this one I have phi y fourth times y prime is equal to the negative 6x here, correct? Okay, so now my y prime will just be equal to negative 6x to the phi y to the fourth. So because this is the implicit equation, so your derivative also going to have x and y's there. It's not just only x as a function, right? So it's x and y's here. Okay, so now let's take a look at the second one here. The second one, whoa, here you said x squared y. So the first things you need to recognize is this is x squared, right? And this is the y, okay? So this is y cubed. Remember, y is a function of what is x. So what I need to apply here? So in order to take the derivative of both sides, what I need to do here first is the product rule on my left-hand side, right? On the left-hand side. Because you have x squared times some function. Okay, let's see if we can do that. So the product rule will tell you, take the derivative of the first one. So x squared, the product rule is 2x. You hold the second one still, so it's y cubed. Nothing to do that. Now you take the derivative of the second one, you hold the first one still. So this is x squared still. So y cubed. So what the rule apply here? Chain rules, right? So that means y cubed, it will be 3y squared. Because of the chain rule, every time you take the derivative of y, I need to take what? Y primes here. Okay, so this is very important, right? So every time you're dealing with y, you need to have y prime because of the chain rule. And now my right-hand side will just be 2. Right, 2x, the derivative is 2. And then 1 is what? 1 is 0, right? Okay, so now I want to solve for y prime. So I minus the 2xy cubed both sides. So I get 3x squared y prime is equal to the 2 minus 2xy cubed. Am I right? Okay, so now I'm solving for y primes here. So what is my y primes here? So y prime will just be this is 3x squared y squared. Then this is 2 minus 2xy cubed. All right. Right, so what is the key things to remember, right? You remember y is a function of x. So every time by chain rule, this is by chain rules, right? So this is by chain rule. So you need to take y primes here. Then the first step here is by the product rule because you see the product of the two functions here. Okay, okay, now let's take a look at the other one here, all right? So now it's the same things here, right? So be very careful. Let's try to see if we'll be able to do that. So the first one's here, 3x squared, just by x, that's easy. What is the derivative? It's 6x minus 5. Oh, I have x times y, right? So I have x times y. So x here and y here. So what rule I need to use? Product rules, right? So the product rule, right? So you take the derivative of x is what? Is 1. So you take y's here. Then plus you hold the first one, x here, okay? So then you take the derivative of y. So this is y to the what? This is y to the first powers, right? So this is y to the first power, so it's 1. But be careful, every time you take the derivative of y, you need to do what? Y primes here. Okay, so what I have in here is corresponding to here by using what? This is the product rule, right? And what is corresponding here? This one's here is what? This is a chain rules, right? Okay, now next, okay, so now we still have, we still have the y squared. So y squared, the derivative is 2y. Every time you take the derivative of y, what you need to do? Y prime. So what is y prime again? So these numbers here is because of what? This is the chain rules, right? So you need to be careful. And then the right-hand side is 10. So what is here? So it's 0. Okay, so now let's simplify it a little bit before we combine here. Okay, so now let's simplify this. So this is 6x minus 5y. You just be careful about your algebras, right? So like we talked about, so it's minus 5x y prime plus 2y y prime equal to 0. Okay, so then you combine the y prime. So you have a 6 minus 5y. All right, and then you combine, you say plus y prime, factor the y prime out, you have 2y minus 5x equal to 0. Then move it. So this is y prime, the 2y minus 5x. So this will be the 5y minus 6x. So what is my y prime here? My y prime here will just be 2y minus 5x. So this is 5y minus 6x, right? So like I said, the idea is not difficult. You just need to be very careful about your algebra and also be careful about the rules you learned before, right? So every time you take the derivative for y, don't forget the chain rule. So you always need to have y primes here. All right, so now let's take a look at our next problem here. They say find the slope of the tangent line for this curve here. All right, so for this curve is here at a point 5, 2. So what is the slope of the tangent line? So we know it's f prime a. This is the slope of the tangent lines here, correct? So I need to take the derivative, okay? So now this is x squared. Right now it's just this one. I have x and y mixed together. So, but I still do the same thing. I want to find the y prime, right? Then I can plug the point and I see what is the slope here, correct? Okay, so now let's take a look at the derivative. X squared, what is x squared? It's 2x. Good. Oh, so this is a 2xy. We just dealt with that. So what rules I need to use here? Product rules, right? Okay, let's try again. Product rule, take derivative of x is 1. The second term, you hold it still. So it's 1 times y. Then hold the first one. So it's x. Take the derivative of the second one. So y is y to the first power. So the derivative is 1 times what? Y prime. Don't forget, that's the chain rule, right? Okay. So then this is a minus. So take the derivative of y squared is 2y. Then times what? Y prime. That's the chain rule. Don't forget that. Then 41 is a constant, so it's 0. All right. Okay, so now simplify. So FOIL. So it's 2x plus 2y plus 2xy prime minus 2yy prime equal to 0. Combine. Okay, so take the y prime out. So you will have a 2x minus 2y and move the 2x, 2y to the right-hand side. So it's minus 2x minus 2y. Am I right? Okay, good. Now in here, now my y prime will just be the 2x minus 2y. This is minus 2x minus 2y. I can cancel the 2, right? So I can have minus x minus y, right? So and x minus y. So this is my slope. So I plug in 5, 2. So y prime will be negative 5 minus 2. Then this is 5 minus 2. So what is here? So this is negative 7 over 3. So what is this one? This is our slope. Okay. And so this is what is the implicit differentiations and you can do for any functions. And we're going to stop the first video here. And so for the implicit differentiations, be very careful. You need to visualize y is a function of x. You just cannot write it. So because of the function of x, so if you have something like x times y, then don't forget this is the multiple. You really basically multiply the two f of x function together. So you need to use the product rules, right? Then every time you take the derivative of the y, don't forget to take the y prime. That's the chain rules here. All right. Okay, that's it. And so we're going to stop our first videos here. Then our second video, we're going to take a look at how do we do the inverse trig functions here. What is the formula for the inverse trig functions? All right, that's it. And I guess I will talk to you in our next videos here. All right, bye.